So we left off at the this function here, which was a function, the arch IO port pin to base function, which returns a pointer of type port T, and so it returns this this IO port to base function here, which has arch IO port pin to port ID function as a parameter, and all this little function does is knock off the pin number and just leave you with the port. And then let's go check out this function here right quick. And of course it's just up here, so we're just here and it's pointing to this. You can see up here arch is a function with a returns a pointer. It's the arch IO port to base, which is what we're returning down here, IO port to base. And this is kind of the heart of accessing the port right here in this part of the function, where it returns the IO port base address, which remember was hex 600 plus the port, which is port R, or that number 15, times the IO port offset. Because remember that all the ports were lined up in ascending orders from port A, and increasing up through all the different ports on the different boards or different microcontrollers, like you see right here. So once again, starting at port A is 0 and going all the way up. Port E is 4, and then you'll see here, with the different microcontrollers. You see the C3 here that's on my board, and then you have all the different ones, and running all the way up to our port port R, which was our 15. So that is used in that. Let me get back to it here. So back to this, to the port to base function, the crux of it. So it was the base address for port A, where all the ports start, 600, and then times 15, basically 15 offsets of hex 20 for each port. And so, because port R was in ascending order, and there was like about 15 ports in between port A and port R. That's why that number, the port there, is used times the offset, and then returns a pointer, and that's returns a pointer to the address of port R. And that's what basically this whole function is doing. So I've tried to sum it up here. Basically this function up here, which is has another function. Well, actually, this one down here, which returns this function up here, has this function as a parameter. I'm getting confusing myself. Basically, it comes down to that it returns a pointer of data type port T from the function port to base, which returns the sum of the port memory address plus the port itself times the port offset. So in this case, like I said, 600 plus 15 times the 20 hex. So the 15 offsets, and because port R is 15 in the ascending list of port modules, each module is offset by 32 bits or hex 20. This will now point to port R's memory address. So going back to our original function, remember this line where we created an instance of the port T structure, a pointer to the port T structure, called it base, set it equal to the arch IO port pin to base function, and through a convoluted number of other functions basically end up pointing to port R in this case. And then it uses the if statement to see if we're trying to set an input or an output. And obviously in this case we want to set it to an output, so it's taking the pointer to the base instance, and then setting the direct set pin, which, if you remember, was one of the register here. You can see the register here, the direct set pin, IO port data direction set, and setting the direct set register equal to the arch IO port pin to mask function, which basically will get rid of the port number and just leave the pin number by adding the combination LED 0, which is the pin and port, ending it with hex 7, which dumps the pin number and just leaves the port number, or leaves the leaves the pin number, sorry, dumps the port number and leaves the pin number. So to conclude, the arch IO port set pin direction function basically creates an instance of a structure, and the structure contains the registers, and by creating an instance of that structure and then stacking all those structures one on top of each other in ascending order from port A on all the way up through the different ports, this first line basically is pointing to one of those structures, the port R structure, in that stack of ascending structures. And then our if statement, querying whether we want to set it to an output or an input, and takes that instance of the structure, accesses the direct set register, and through a mask sets the pin we want, in this case our pin 0, and sets it the direct set register and pin 0 to a 1 to make it an output. Now when we move on to discuss the OLED display on the demo board and how to drive it, we'll be using a lot of the similar type of structures, setups for the peripherals, like USART for the transmission of data over to the onboard chip of the OLED display. And you'll see that the structures are set up similar, and they're creating an instance of those structures and using lots of different functions to access the what's inside the structures to drive the display. We'll get into that in a later video.